As we look at lesson 5.4, remember we are starting to talk about multiple angle identities in the few minutes we talked about this yesterday. And we had started on number 1. We were told sine of theta is 4/5 and cosine of theta is less than 0. And we were asked to find sine of 2 theta, cosine 2 theta, and tangent of 2 theta. And if you look at the identities for sine, cosine, tangent of 2 theta, realize we're going to have to know sine and cosine. And so that is what we're working on right now, is finding sine and cosine. By sine being 4/5 and cosine being less than 0, positive sine, negative cosine puts me in quadrant 2. So I drew my triangle in quadrant 2. Remember, your angle of reference is always at the origin, and then your triangle always lays on the x-axis. Okay? From there, sine, we talked SOHCAHTOA, right? So opposite over hypotenuse, that put the 4 and 5. Where'd this magical 3 come from?
Mario.
Okay, essentially Pythagorean theorem, right? When we never really talk about Pythagorean triples, but 3, 4, 5 is a known right triangle. Okay? 3, 4, 5 is a common right triangle. There are lots of what we call Pythagorean triples, where a set of 3 numbers that fit the Pythagorean theorem. So, but that was essentially Pythagorean theorem. Why did we mark it negative?
Because
Yeah, we're in quadrant 2, and when you're in quadrant 2, that x value is going to be negative because you're going left. Okay, so we have that information, and what we can do right now, real quick, before we start into the other pieces, is I'm going to write down our necessary information. We already know that sine of theta is 4/5. What about cosine of theta? Negative 3/5. And tangent of theta?
negative 3 or 4. No, 4 over negative 3.
Negative of 4 over 3, right? I don't care where you have the negative there, as long as it's a negative 4/3. Okay? Okay, so that is our information to get us started. Now, the first question we're being asked is to find sine of 2 theta. And folks, I'm cramming stuff in because I know there's a lot to get in here. Okay, so just FYI. How do we find sine of 2 theta?
Do you have to
Well, let's look at the double angle identities and all that.
Oh, yeah.
Let's
That might be a
just,
smart place to look at.
let's just get started looking at that.
Okay, what is our double angle identity for sine of 2 theta?
2 sine u cosine u.
Okay, 2 sine u cosine u. So it's going to be 2 sine theta cosine theta. Do we know that information we can plug in?
Mhm.
Yeah. 2 is 2. What's sine theta? 4/5 times what's cosine theta?
Negative 3/5.
Negative 3/5.
We can no.
And now we're going to
Multiply
multiply them together. What's 2 as a fraction?
2 over 1.
2 over 1, if that makes life better for you.
Right.
What are we getting?
Negative 24 over 2.
2 times 4 is 8, times negative 3. Ooh, I agree with negative 24.
Oh, not 10,
24 over
25.
25.
Good.
Okay,
Great.
there we go.
25.
Negative 24 over 25.
My finger slipped.
That is our sine of 2 theta.
Yeah, I'll do that. You should know.
Okay? So as long as you know sine and cosine, you can find sine of 2 theta using that double angle identity. We're also asked to find cosine of 2 theta.
Oh my god. Do we have to use, is it just one of those equations or is it all 3 of them?
Well, here's the deal. Cosine of 2 theta is equal to any of those 3 items.
So pick your poison, essentially.
Essentially, yes, pick your poison.
Oh, all of them kind of suck.
Okay?
Almost.
And now, in a situation, if you only knew cosine or only knew sine, there'd be, you definitely know what to pick. Other than that, it doesn't matter. I personally was going to pick the top one,
I know, I was thinking, I kind of like the top one.
unless you guys have a preference. And here's the deal. Pick your own and meet me in the end if you want.
I'll pass.
So cosine of 2 theta is cosine squared theta minus sine squared theta. What's cosine?
Negative 3/5.
So negative 3/5 squared minus what sine?
4/5.
4/5 quantity squared. What is negative 3/5 quantity squared?
9 over 25.
9 over 25. 4/5 squared is
16 over 25.
16 over 25. 9 over 25 minus 16 over 25.
Negative 7.
Negative 7 over 25. And that is cosine of 2 theta.
Okay.
And one more.
Tangent.
We're being asked to find tangent
Which one is so easy?
of 2 theta. And what about tangent of 2 theta? What identity are we using? Two tan theta over 1 minus tangent squared theta.
You and the equations like there.
And here's the deal. Could you write this all out with u's instead?
Yeah.
But I know you guys don't care for u's.
It just, it didn't bother me yesterday when you were looking at it. But
I
now
don't
that
care
I'm
for
looking
you.
at it, I'm like,
Now that you're having to write it a bunch. I'm writing thetas. I'm writing thetas because the problem was done in thetas.
Yeah.
X, U, theta. It all works out in the end. I don't know. Some teachers may be particular about that. I'm not. Pick your variable and use it. Okay, so tangent. 2 times, what is tangent?
4 over negative 3.
Negative 4/3 over 1 minus tangent squared. So negative 4/3 quantity squared.
Yep.
That's such an
Okay, so now we're going to do some math. 2 times negative 4/3.
Negative 8 over 3.
Negative 8/3.
I was getting ready to say that.
Over.
1 minus.
the awful.
Now we have 1 minus negative 4/3 squared. What is negative 4/3 squared?
16
Positive
over 9.
16 over 9.
So this is 16 over 9. And so we have 1 minus 16 over 9.
Which would be 9 ninths.
So we want to make that 9 ninths minus 16 ninths.
Which would be 7 ninths. Negative 7 ninths.
So now I'm going to have negative 8/3 divided by negative 7 ninths.
Common denominator.
Nope.
No. Okay. No, keep change flip.
Change flip. So we're dividing fractions. So we're going to multiply by the reciprocal. And I'm going to say negative 8/3 times negative 9/7.
72 over 21.
72 over 20.
I personally make a cross cancel before I get 72 over 21 because I don't want to have to reduce 72 over 21. So I personally am going to say
Mario. 24 over 7. Oh my gosh.
Negative.
how about positive 24 over 7?
Negative.
Yep.
Yeah, you're so.
Sorry. Mario, quit being mean to everybody.
I know. I need to stop.
You need to stop.
Okay,
Need to work on that.
so we did some math, right?
Yeah.
We did really a whole lot of basic algebra and basic math in here. Okay, we didn't really do anything
I kinda
fancy.
like this.
Oh my gosh, wait.
I feel it's gonna
We
get
could
worse.
just.
Everything's a
Oh,
little
it's
different,
definitely
so.
They're all
Okay.
the same, like, combination of numbers. It's 24,
No
25, and
way.
7.
As they should be.
Is that a way you can check your answers?
Probably. Because if you think about it, it's still SOHCAHTOA,
Yeah.
except of 2 theta, so it's a different angle than theta. It's double the angle. Okay, so you can look at, because if you look at the relationship between opposite and adjacent and hypotenuse, it's still there. It's just 2 theta is our angle now instead of theta.
So then, if we had found those two, did we really have to go through all the math to find tangent, or could we have just
I guess not, but I still feel we need to
Well,
practice this,
absolutely?
because here's the deal. What if the question only asked you to find tangent of 2 theta?
Mhm.
Then we have to go through this process.
If
So
we have a question like that on like homework or on a test, would you let us just instead of
well, in homework right now, I definitely prefer you practice it out.
Yeah.
I haven't thought this far ahead about the test,
Sorry.
and I really don't remember what I've done in past. I don't really remember what kind of problems I put in relation to this in past years, so I can't think about,
Mhm.
But for right now, I would definitely say practice it, just because if nothing else, tangent is probably the worst simplifying we had to do, and so making sure we know how to do that simplifying. Okay, and we've got several different problems here, guys, and they are all a little bit different today.
That's cool.
So, we're going to go from there. Okay, you guys ready to move to 2?
Oh, not really. I just read it.
You ready?
Okay. Rewrite cosine to the 4th of x in terms of trig functions with no power greater than 1. So what are we trying to do to the power?
Power.
We're trying to reduce the power. Now, the power we're trying to reduce is a power of 4. What do our power reducing identities have?
2s.
2's. So, as we get started with this, what do you know about cosine to the 4th? Well, and I wouldn't even think factor, but just how can this break apart? Cosine to the 4th is the same as what times what?
Cosine squared times cosine squared.
Cosine squared times cosine squared, or you could say cosine squared quantity squared, but for what we're getting ready to do in the next step, I'm going to write this as cosine squared x times cosine squared x. Why did I choose to go cosine squared x times cosine squared x? Because I'm trying to rewrite this with no power than greater than 1, and I need to get to my power reducing identities. Okay? Now, what do we know about cosine squared x?
It equals 1 plus
cosine 2u over 2.
Okay? So can we replace that?
Mario.
Just multiply them to each other.
Okay, so according to our identities up above, we can replace cosine squared x with 1, totally skipped over the 1, wrote my parenthesis, 1 plus cosine 2x over 2 times 1 plus, goodness, can't write, cosine 2x over 2. Are we there?
Not
That's where I'm at.
that one's good.
Okay. So, as we work to do some math here, what has to happen now?
You gotta foil.
Okay.
Yeah.
We got to FOIL those tops.
Yep.
Okay, in other words, we're multiplying the fractions. And in order to multiply the fractions,
That's all.
the numerators do need to FOIL. So, I'm going to put this together as one big fraction. What's my denominator?
2, 4.
2 times 2 is 4. On top,
Good job, Kylie.
FOIL with me.
Yay.
First times first. 1 times 1? 1. Plus, outsides. 1 times cosine 2x.
Cosine 2x.
Cosine 2x. Insides.
Another.
Cosine 2x times 1.
Another
Cosine 2x.
Another cosine 2x. What is cosine 2x plus cosine 2x?
2 cosine 2.
2 cosine 2x. Plus, what is cosine 2x times cosine 2x?
Or cosine squared 2x.
Okay. So cosine squared of 2x.
It's basically the same thing.
But if you write that squared after, I'm going to count it wrong. It's not the same. You can think it's basically the same all you want in your brain, but if you write that squared after, it means just the 2x is squared, unless you put parentheses around the entire cosine 2x. So in other words, I could write cosine 2x squared, or cosine squared 2x, or I could write cosine of 2x quantity squared. Those are equivalent. Okay, those are good. If I write cosine of 2x squared like this, all I'm squaring is the 2x, and that is not equivalent. Okay? So, just kind of an FYI there. Okay. Am I done?
I don't believe so.
Why not?
We have now a square.
See, I was prepared to answer that.
We have a squared back in there again. So the problem with starting with a higher power like the fourth is that now we still have a squared. And that's a slight issue. Okay? So, thoughts on what we need to do?
Do we have to do it again?
Yeah, kind of. Okay, here's the deal. This cosine squared 2x is an issue because we need no power greater than 1. And right now we have a power greater than 1. So, we're going to do this again. Now, as we look at this right now, we already have a fraction, right? And when we substitute in for cosine squared, we're going to have a fraction within a fraction. So as we get ready to substitute, I'm going to rewrite this also in a different form. I have a denominator of 4, yes? I'm going to put that denominator of 4 with each of the 3 pieces. Meaning, what is 1 over 4? 1/4. That one wasn't a trick question, okay? Now, what is 2 cosine 2x over 4?
Cosine 2x over 2.
Okay, so the idea is that the 2 and the 4, the 2 out front, and this 4 can reduce, yes? And so Sophie said cosine 2x over 2. I'm actually going to write it as 1/2 cosine 2x. So in other words, cosine 2x over 2 would not be wrong. It's just kind of a matter of the form I'm trying to get it to. Okay? Plus. Okay. Now, what about this one when we divide it by 4? Out front, that's going to put a what? 1/4? Are we okay with that? Now, how fancy can I be? Can I go ahead and switch this out also? Will you allow me to do that? As in, can we go ahead and take cosine squared 2x and replace it with whatever I'm supposed to replace it with?
Go for it.
Yeah.
Now, what does cosine squared 2x replace with?
1 plus cosine 2x over 2.
Almost. Okay, so our identity was 1 plus cosine of 2x, I'm going to pause on that for a moment,
Oh, shoot, I forgot that 2x.
over 2. Now, okay, so there's a trick. There's always a trick. Valid point. Valid point. Okay, so the trick we run into here. What's in my variable position? 2x. When you look at the identity up at the top, what's in this position in the identity? What's it say up top? It says cosine squared of u. If you look at the identity at the top of your paper, it says cosine squared of u. We essentially have 2u, which makes a difference here. So this is a trick. Because here, when I go in to put this, what's it supposed to be? It's supposed to be cosine of 2u, right? But what is our u in this case? 2x. So if right here is supposed to be 2u, that means 2u is going to be doing 2 times 2x. And what is 2 times 2x? 4x. It's a trick. Okay? Did we somewhat follow the trick? Okay. From here, it's a matter of cleanup. Okay, because I believe when you see these problems in homework, if I recall, I'm trying to remember how it says it, but they kind of give you the beginning and the end, and I think they have you do it as a proof where your job is to work the middle. And so that's why I'm trying to get you all the steps so you know what to do here. I would go ahead and clean up this back part in that what I just substituted in, can we break that into 2 parentheses or two pieces? In other words, sorry, I'm being tongue-tied. Take this one fraction that's in red and break it into 2. Kind of like what we already did the first time round, yes? So, okay, sticking with 1/4 out front, yes? Still sticking with 1/2 cosine of 2x, yes? Now, I think I'll take 2 steps to do this. We still have a 1/4 out front. That 1/4 is eventually going to distribute, but I'm going to take an extra step. In the red, break this into 2 pieces. The first part is going to be 1/2, because it's 1/2, plus, how am I going to write the next part?
Cosine 4x over 2.
Okay, cosine 4x over 2, or
Cosine 2x.
if we put that 2 out front as a denominator, it's 1/2 cosine 4x. And what I'm trying to do is I'm trying to match this up with everything else here. Okay? And so everything else has the fraction out front. Okay. Is there any cleanup I can do? Well, wait, I forgot. We need to distribute. Then I'll ask about cleanup. Sorry, don't let me skip steps. So if we distribute 1/4 plus 1/2 cosine 2x stays. Distribute the 1/4, what do we have?
1/8.
1/8 plus
1/8 cosine 4x.
1/8 cosine 4x. Now what I started to ask last time.
Clean up.
Clean up.
Can't we? I mean, we
What
just
can
gotta
clean up?
Make everything terms.
Well, you can
Oh,
add
1/8 and 1/4.
Okay. So if you look here, we have 1/4 and 1/8. What is 1/4 plus 1/8?
3/8.
3/8, because what is 1/4?
2/8.
2/8. And 2/8 plus 1/8 is 3/8. So 3/8 plus 1/2 cosine of 2x plus 1/8 cosine of 4x. Can I add my cosines?
No, they don't have the same.
They don't have the same coefficient.
They don't have the same, I would say, variable piece.
Yep.
One's cosine of 2x, the other's cosine of 4x. In order to add cosines, they have to have the same insides. Okay. This is one way you could leave your answer. Okay. I'm going to show you an or that could possibly help with homework, though. Because the other option is, I believe, what the book does, you have to be able to do, I think. Every term has a fraction, yes? What would be the common denominator of those 3 fractions? 8. So the other option here is we can factor out an 8th. Now, if we factor out an 8th, If you have 3/8 and you factor out the 1/8, what are we left with? 3. If I have 3/8 and I factor out the 1/8, I can't be left with the same thing. I have 3. Plus, now, it's 1/2 cosine 2x, but what do we know about 1/2? It's 4/8. So if I have 4/8 and I factor out the 1/8, what am I left with?
Oh,
Dang it.
2.
We're just being left with the numerator here. You're way overthinking this. Plus, if I have 1/8 and I factor out the 1/8,
1.
we're left with 1. Which 1 you could write or not write, and I could just write cosine of 4x. This is an acceptable option also. Now, depending on what, as I said, I didn't look at the homework this morning to refresh my memory, but I think this problem is more like a proof where they give you the beginning, they give you the end, your job is to fill in the middle. Okay? Your middle is going to have similar steps to this. Now, you might have some easier pieces where, hey, they might actually just start with a cosine squared, but I think you do have some that start with a fourth as well that are a little bit more complicated. Okay, so that will be something you'll have to work with. Okay. Questions before I try 3? Okay. Let's try 3 then. Given that cosine of theta is 7/25 and sine of theta is greater than 0, find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2.
101.
And without anything else, I'm being told quadrant 1.
Yeah.
Okay,
One thing, right?
so why quadrant 1?
Because sine is and cosine is positive.
Everybody's positive. So since cosine's positive and sine's positive, this is going to be a quadrant 1 triangle. And if you look, realize we're pretty much doing the same type thing we did up in question example 1, except now we're not going to be using our double angle identities. We're going to have to use our half angle identities. Okay? So I'm going to start by drawing my triangle. You guys already told me quadrant 1. Remember, theta is at the origin on the x-axis. That puts my right angle here. This is quadrant uno. What do we know about the sides of my triangle right here? Adjacent 7, hypotenuse 25.
The second Mario magically tells the other numbers. It's like, I want to do it myself, but then
Well,
I'm
25
get it
squared
before I
would
get it.
be.
Mario, what's the answer?
25 squared is 625.
Yes,
Oh.
625.
7 squared,
49.
49.
Hang on.
625
Minus 49.
minus 49 is
Wait.
576. And the square root of 576 is
24.
Whoa.
24.
I did it.
Okay, so we have that information. And let's see, with that information, if you look at the double angle identities, or excuse me, half angle identities, you have to know cosine, which was already given, yes? 7/25. You also have to know sine. What is sine?
24 over 25.
24 over 25. Should anybody be negative here?
No.
No, because we ended up in quadrant 1. Okay. Just got to ask the questions here, right?
Do we need to find tangent? Or should we at least have
If
7
you
over
check your
24.
half angle identities, none of them use tangent.
Oh, okay.
So, no, we don't have to find, I mean, you can find tangent all you want, but
I was
I
gonna
just didn't
write
write it down.
We don't like that.
Okay, so we're being asked to find sine of theta over 2. Okay, guys, what about sine of theta over 2?
Plus or minus.
Plus or minus the square root. One minus cosine theta over 2.
That's what I.
Okay, so
7 over
I'm going to fill in my square root, or I'm going to fill in my information. 1 minus, what was cosine? 7 over 25 divided by 2. Now, it says plus or minus there, yes? At some point, it could be now, it could be later, but at some point you have to make the decision, is it plus or is it minus?
plus.
And why is this going to be plus?
Because we're in quadrant 1.
Okay, we're working in quadrant 1. Okay, so that's always something you have to decide. And I guess one thing you also do need to take into consideration here, that this was theta that put us in quadrant 1, yes? Theta divided by 2 is going to be an even smaller angle. So is theta divided by 2 still going to be in quadrant 1? Yes. So that is always something to think about there. But because we're in quadrant 1, it is positive. So I'm going to drop off the plus or minus for that reason. Okay, do some math. What is
25 over 25.
1 minus 7/25? So 1 is 25 over 25
Maybe 18.
18 over 25.
minus 7 over 25,
Keep changing.
which is 18 over 25. What do you know about 18 over 25 divided by 2?
Keep change.
Keep change flip. So this is really going to be 18 over 25. Instead of dividing by 2, it's going to be multiplying by 1/2. Right? Dividing by 2 is multiplying by 1 over 2.
It should be 18.
Ugh.
9/25.
Okay.
I am a cross canceler through and through. I know you guys aren't necessarily, but if I cancel those, 2 and 18 become 1 and 9.
3 over 5.
So it's the square root of 9/25, which is indeed
It was not there yet. So
3/5.
Where are you getting the 3 over 5?
Hoorah.
Notice I put in the intermediate step
Thank you.
of square root of 9/25. For everyone out there sitting there saying, what?
I realized it just went there.
I thought that was you cross canceling. I'm like, where?
I-
You get 3/5. I was like,
No,
I thought that was.
no. So the intermediate step, did everyone catch the intermediate step?
Yes.
It was square root of 9/25. But those are both magically beautiful, perfect squares, and the square root of 9/25 is 3/5.
Okay. That makes sense.
Okay, next part.
Fail.
Now we are looking at cosine of 2 theta. Excuse me, cosine of
Theta over 2.
theta over 2. What's my formula?
Plus or
Plus or
minus the square
minus.
root of 1 plus cosine u over 2.
Okay, plus or minus the square root of 1 plus cosine theta all over 2. Well,
Positive.
you can decide about that plus or minus right off the bat.
It's got to be
1
positive.
plus 7 over
And
25.
Water.
we're in quadrant 1, so we're talking positive. 1 plus, what was cosine theta?
7 over 25.
7 over 25 divided by 2. What is 1? 25 over 25
32.
plus 7 over 25.
32 over 25.
So it's 32
Over 2.
over 25
Oh, shoot.
divided by 2. All under the square root. But in order to divide by 2, I'm going to suggest 32/25. Divide by 2 is multiply by 1/2.
16.
My brain's going to cross cancel.
16 over 25, square root of that is 4. Oh,
I cross cancel.
Okay. If I cross cancel, I have square root of 16 over 25, but I know that is
4 over 5.
4 over 5.
I knew what that was from.
I even crossed.
This time you're caught up. It all makes
Yeah.
sense, right?
Tangent is gonna be 3 over 4, but we have to do the work first.
We do have to do the work. I really just wanted to write it down. It's,
We do need to practice the work because, again,
They're not all gonna be this.
the steps, okay? And I honestly, I really should have glanced at homework because I'm totally not remembering what exactly is in there in relation to these. It could be something where it's find all three. But when it's not, you have to know how to use these identities independently. So, tangent
Sine
of theta over 2 is what?
Sine theta over 1 plus cosine.
Sine theta over 1 plus cosine theta. Okay, sounds easy enough, yes? What is sine?
24 over 25.
Over 1 plus 7.
Yeah.
Okay, sine is 24 over 25 over 1 plus cosine, which is 7 over 25. Sorry, I had a little bit of a delay. I was processing. Okay, do some math.
Over 32.
We know we have 24 over 25. 1 plus 7/25, we just did last part, didn't we?
32 over 25.
25 over 25 plus 7 over 25. So 32 over 25. How do we divide fractions?
25 over 32.
Keep 24 over 25. Change division to multiplication and flip. And we have 25 over 32. Now, you can multiply all you want there, but I am not multiplying those big numbers out because that is just crazy speak. 25 and 25, cancel. Now, if you want to go ahead and put 24 over 32, that's fine because you're still reducing. But 24 and 32 are going to both divide by,
6.
go big. 32 doesn't divide by 6.
8.
8.
which is
8's the 1.
Did you just say?
3 plus 4.
Okay,
3.
divided by 8, we end up with, shocker, 3/4.
Huh. Real weird. That's fine.
I know, that was just such a surprise, wasn't it?
32 divided by 6, isn't it?
No.
No.
No, it does not. Which is why I was like, no, go big, thinking you just said the wrong number. That was like, no, wait, you said a number that isn't even possible.
30.
30.
Okay,
Shoot.
It's 16 divided by 6.
32 divided by
okay, we have one more. Maybe we can get it in?
5 minutes.
We'll see.
We can do it.
Okay,
How much time later?
number 4. Ask us to find, use half angle identities to find the exact value of sine of 3 pi over 8. In other words, not the calculator answer, but an exact answer that's going to involve fractions, square roots, and all that fun jazz. Okay? Now, in order to think half angle identities, and we may have to talk about this some tomorrow, we'll see. But we are working with sine of 3 pi over 8, yes? That's our given problem. A half angle identity says sine of something divided by 2, yes? That's how my half angle identities start with, is it is something divided by 2. We need to know what that something in there is. Thoughts on how to find something?
Yes, and sure.
And here's what I'm going to say, guys. What is right here has to equal what is right here, yes? So in here we have 3 pi over 8, and it has to equal something divided by 2, yes? So what are we going to have to do?
Get to the bottom of it.
divided by 2. Right? You just put that
If we're trying to find this right here, and actually the formula uses u, right?
Yeah.
So there we go, I heard it. If my goodness. Okay, because right here we're looking to put u, whatever u is. So if 3 pi over 8 is something is u divided by 2, how do you find u? You multiply by 2. So that means I'm going to have to do 3 pi over 8 times 2. Which, FYI, this is always the step you'll take here. What is that?
6 pi over 8.
Which is? 3 pi over 4.
Yeah.
So that is u. And so what am I putting up right here? 3 pi over 4. And that is what you'll use as you go through your formula.
So put in the sine? Cosine?
For the half angle?
Well, I guess you took cosine.
That's the angle you're going to use in our sine half angle identity. So what is our sine half angle identity?
Plus or minus the square root of 1 minus cosine.
Got my square root. Okay. So we'll start with plus or minus the square root of 1 minus cosine of u. What's u?
3 pi over 4.
3 pi over 4. And then all divided by 2, correct?
Yep.
And I'm just going to pause there, and we'll pick up tomorrow. Because I need a little bit more than my minute left to explain that.
So is homework due tomorrow? Start it.
I would say do what you can in homework tomorrow, because what I'll do is I'll finish this, and then we can also start doing some homework questions. So I'll have to look and see which section it is. But there's like 3 different sections, maybe 4 different sections. Do what you can. There's one section you're not going to be able to maybe do quite yet. Does that make sense?
Yeah.